So even though we have two down conversion steps, you have mixing spurs happen even more effectively, because more the number of yellows, mixing spurs will happen effectively because spurs will depend on yellow. But yes, but if you have additional IF filters in yellow, it will further complicate the design, and mixing spurs will also become difficult to manage. So mixing spurs are coming from yellows, right? So if more number of yellows are there, more number of mixing spurs. The dual down conversion has two yellows, so definitely you have at least many number of mixing spurs happening in the two conversion itself. If you go for more number of conversion, then definitely this mixing spurs will be a serious issue into your system. So that is the reason why Max, all the heterodyne receivers employ only two-step conversion. They will not go beyond two, because in the two itself they will convert your desired signal from RF to IF. So this conversion from RF to IF is possible in this conversion itself from using a two down conversion, and more number of IFs you will have this mixing spurs causing a lot of issue in the receiver. So you have to clearly understand how image and spurs are going to be different. Image is going to be occurring at some frequency away from your message, but the spur is going to be interfering with exactly the message frequency because of the non-linearity of your mixer, and also the infinite Fourier series terms of your oscillators. So how to overcome so all these issues we have seen in the receiver? So much of issues are there in the receiver. So how do modern heterodyne interferer receivers are going to overcome all these issues? So the receiver employs several filters. So mostly if the filters are bulky, you have an off-chip filter, you will have provision to solder the filter externally, and it will have two LOs, and thus it has become obsolete. So today's architecture omits all the off-chip filters except for the front-end band select device. So previously, before technology came, you need to have lot of off-chip filters and oscillators, but with advancement in fabrication and technology, it is going to have no off-chip filter, and only the first band select filter you have, that is going to be the only filter inside your device. So with the omission of a highly selective filter at the first IF, no channel selection occurs at this point, thereby dictating a high linearity to the second mixer. Since you are removing all the filters just because they are going to be off chip, our mixers have to be highly linear. So the responsibility now falls on the mixers, because my filters are going to occupy a larger amount of space, or it has to be connected externally. So I'm not going to invest so much to make my device bulky. So I'm going to have only one filter at the front end to filter my band of frequency, and afterward there's no filtering is going to happen, and I'm going to have a highly linear mixers in my circuit. Further, you have CMOS mixers which are very highly linear, so they are going to help you in that. But the lack of selective filters means secondary image may become serious. Okay, because first mixers are linear, okay, you can suppress the image, but when you don't have the when you don't have filter after your second IF, the secondary image may become a serious issue. First, at the starting itself, since you're having a filter, there is a chance that the image gets filtered there itself. So your first image is filtered. When you go for the secondary image, since there are no filters beyond the entry of your receiver, there is a serious issue that the secondary image may become serious.